We addressed two types of special triangles in class. One were the 30, 60, 90s. This video is going to address the other ones, the 45, 45, 90-degree triangles. In class, we proved the relationship between the sides. In this video, we're just going to use what we figured out, which is basically that the two legs of a 45, 45, 90-degree triangle are the same, which makes sense because, as we know, a 45, 45, 90 is a type of isosceles triangle. And through the converse of the base angles theorem, we know that these two legs must be the same if these two angles are the same. Now, through the Pythagorean theorem, we ended up proving that if you knew the side length, or the leg length, then you'd be able to know the hypotenuse length. And basically, all you need to do is multiply it by root 2, and you're there. So we're going to play around with two examples and see what happens if we know the length of a leg, see if we can solve for the hypotenuse, and then vice versa. If we know the hypotenuse, can we solve for the leg? So here in example 1, I know that the leg is 5. Since it's a 45, 45, 90, it's an isosceles triangle, so that means the other leg is 5. And if I look at my relationships over here, the hypotenuse is just whatever the leg is times root 2. So here the leg is 5, so that makes the hypotenuse 5 root 2. Done. Now in example 2, I tried to trick you. I didn't write 45, 45, 90. However, I did write these little markings, meaning that these two angles are congruent. And the only types of congruent angles in a right triangle that are not the right angle are 45 degrees. So we're also dealing with a 45, 45, 90-degree triangle. Now, what's the relationship between the hypotenuse and the leg? How do I go from the hypotenuse value to the leg? Well, instead of multiplying by root 2, I need to divide by root 2. Because whatever this is, if I divide it by root 2, I'll get a, which is what I want for the side length. So let's see, 10 divided by root 2 is what? Well, we can't leave it like that, because as we know, with all our rules with radicals, it's not good to have a radical in the denominator. So how do we get rid of it? Well, we can always multiply a fraction by 1. So here, 1 is going to take the form of root 2 over root 2. And then how do I multiply fractions? I basically multiply the numerators, and then I multiply the denominators. So we get 10 radical 2 over radical 2 times radical 2. And as we know, if I have radical 2 times radical 2, I'm running out of room here, I'm basically going to have radical 4. I'm going to keep the top. And what is root 4? As you know, it is 2 which means, in the end, we can simplify this by doing 10 divided by 2, which is 5 radical 2. So the side length is 5 root 2, and then this is the same, so this is also 5 root 2. So we have finished the example. So these are definitely the easier of the two special triangles. If we're going from leg to hypotenuse, we simply multiply by root 2. If you're going from hypotenuse to leg, you simply divide by root 2. So my suggestion, any test or quiz, make sure you write this down as soon as you get the piece of paper, and then you're not going to forget what to do.